Good afternoon, everybody. As you can see, you have Mr. Hartley here for class today during A period. He should have collected your homework from yesterday from you. That was page 347, numbers 8 through 13. That was over substitution. Mrs. Rogalin will be back tomorrow, and then on Tuesday, I start back here with you for the rest of the school year. So today, what we're going to do is we're going to talk a little bit more about substitution. And we are going to basically go over it a little bit more, and hopefully you guys are doing well. So first up, let's talk about our warm-up here. It says determine the solution to the system of equations. The first thing I need to reiterate to you is that a system of equations just means there's more than one. So as you can see on both of these graphs, there are two lines, meaning there were two equations. Okay, these are systems. Now here it says, what's the solution? Okay, determine the solution. So if you have a graph, where does the solution happen? Well, the solution is the point that is on both lines. So in this case, it is where they cross. So right there. So what is the ordered pair of that point? It is 1, 1. That's the solution. And number 2, this is where they intersect. That's the solution. What is that point? Remember, the x's come first and then the y's. So those are the solutions. Now it says determine the equations in the system. So the equations are whatever would make the line. So you should know from before Christmas that if I'm going to write the equation of a line, it's got to be in that form. Remember, the b is our starting point, the m is the slope. So let's take a look at this line right here. I'm going to call it line A. So for line A, where does it start? Where does it cross the y-axis? It crosses right there. So that's the B. That's the number on the end. So there should be a +4 on the end of this. Now what's the slope? So how do I get from this point to this point? Well, I have to go down 1, 2, 3, and I have to go over 1. So 3 over 1 is just 3. So that would be your slope of 3x. Okay, let's look at line B over here. Again, it's going to be in the same form. Where does it start? Where does it cross the y-axis? Well, it crosses the y-axis right here. So that's my number on the end. And now I need the slope. How do I get from this point here to this point here? Well, I have to go up 1, 2, 3, and over 1. Up 3 over 1 is just 3. Now I notice I made a mistake in line A, because if you remember, I counted down 3 to get from that point to that point, so that means my slope should be negative. So there's that fix. Okay, let's do the same thing over here. We'll call this line A. Same form. Where does line A start? Right there, which means I got a +2 on the end. Now how do I get from that point to this point? Well, I have to go down 1, 2, 3, 4 over 1. 4 over 1 is just 4, and because we were going down, I'll put a negative on it. Let's do line B now. For line B, it's going to be in the same form. Where does it start? It starts right here. So I'm going to put a -3 on the end. And to get from this point to this point, I have to go up 1 over 1. That's just a 1. So you can put a 1x there, or you can just put an x. You don't necessarily have to put a 1 in it. Okay, so that's our warm-up. Let's go ahead and let's go on to our notes today. It says solve by substitution. Now, from yesterday, you know if you're going to substitute, you have to take one thing out and put something else in. Okay? Yesterday, you learned that you had to get something alone. You had to get something isolated. You had to get something by itself. And from yesterday's lesson, you learned that you wanted to get alone the variable that has a coefficient of 1. So the variable that has a 1 in front of it. So if you look at this first problem, I see that this y right here has a 1 in front of it. So that's what I'm going to solve for. How do I get that y by itself? Well, I got to get rid of that 2. It's being divided by 2. So I'm going to multiply by 2. And when I do that, I have to multiply this entire side by 2. So those will cancel. It'll be y equals. Now I'm going to distribute that 2. So it'll be 4 minus 2x. Now you can see that the y is now by itself. So I'm going to take this and I'm going to put it in for the y right there. So what will that look like? The 3 stays, I take out the y, and I put in what the y equals. And now this becomes a regular equation. First thing I'm going to do is distribute. Then I'm going to combine my like terms. Notice that 6x minus 6x will cancel, and I'm left with that. Well, you should remember from back when I was teaching you in September and October, that's a true statement. So if there is a true statement on the end, that means there are infinite solutions. Okay, there are infinite solutions. Meaning, those two lines are directly on top of each other, meaning they don't cross at just one point. They are directly on top of each other. They are crossing at infinite points. All right, let's take a look at number 2. Well, if I look at number 2, I don't have a variable that's all alone, so I need to get a variable all alone. Well, you might say, well, take a look at either this w or this z, because there's ones in front of both of those. But I'm going to tell you to hold off on doing that right now, because if you look at this equation, these z's can be combined. 3z minus 2z is just 1z. And now I know exactly what that z equals, so I can put it in right there for z. And that's my new equation. This becomes very easy to solve. That's my w. Okay, now you don't have to go back and plug that back in, because I already know what z equals right here. So remember, I'm going to make my ordered pair. Where do they cross? We're going to go in alphabetical order, and that will be the point where those two lines cross. All right, let's take a look at this one. Again, I do not have a variable that's isolated. The variable that has a 1 for a coefficient would be the easiest, which would be this r right here. So how am I going to isolate that r? Well, I'm going to get rid of the 5. Now remember, that 5 cannot go with that s. So we need to keep them separate like that. I now know what r equals, so I can take this and I can put it in for the r right there. What will my new equation look like? Again, folks, this is called substitution. I'm taking something out and I'm putting in what it equals. Let's distribute. Combine your like terms. And solve. And you will get a repeating decimal here. I would suggest you take that 0.6 repeating and you turn it into a fraction. In this case, you will get 2/3. Now remember, that's only half of my answer. I got to take this and I've got to put it back in right there. So I'll have r equals, and you should be able to type that right into your calculator, and your calculator should tell you that r equals 1. Now, I hope you guys aren't just writing this down and not just taking my word for it. You should be doing this on your calculator and making sure everything's working out right for you. So my ordered pair where these things cross, remember we're going alphabetically. We're going to go r and then s. So this would be where those things cross. Now you can see here, there's a fraction in that answer. So it's a good thing that we did substitution, because if I were to graph these two things, they would not cross at a nice point. Okay, these things would cross in between 2 points. Okay, let's take a look at number 4. Again, I do not have a variable that's isolated, but I do have this n that has a 1 in front of it. So I'm going to get that alone. Remember that n has a negative in front of it. The 12 and the 8 cannot go together. I'm going to put my term with the variable first, so it looks like that. Now, in order to get that negative off of there, I'm going to divide everything by -1. And it should look like that. Remember, when you divide by a negative, you're just flipping the symbols. So this will go in up there, and I'm going to have a new equation. I'm going to distribute. Be careful here, minus times a minus is a positive. I'm going to combine my like terms. And I'm going to solve. And when you do that, you again are going to get a decimal answer. I would suggest turning that decimal into a fraction, and you should get that. Now I'm going to take this m and I'm going to put it in right there. Again, you're typing this straight into your calculator, and you should get a mixed number of 5 and 5/11. So again, this thing does not cross at a nice point. We're going to go in alphabetical order, and it looks something like that. Okay, hopefully we're getting the hang of this here, folks. Let's flip it over to the back. I got 2 more for you. All right, take a look at number 5. Again, there's no variable that's isolated. There's no variable that's all alone. But I have this y that has a 1 in front of it. So let's get that y by itself. There's still a negative in front of there. Excuse me. I'm going to put the term with the variable first. I've got to divide by that negative to get rid of it. And this is now what y equals. Let's take this and put it right in there for y. My new equation will look something like this. I took out the y, I put in what it equals. Now we're going to distribute, combine my like terms, and solve. And this will give you a nice number of 4. Okay, so take this 4 and substitute it in so we can figure out what y is. Type it into your calculator, and you should get that. So in alphabetical order, these things actually cross at a nice point. Okay, again, remember, this is an alternative to graphing. Some of you don't like graphing. Okay, if you've noticed, none of these equations have been in slope-intercept form. So I wouldn't want to graph them in the first place. So we do substitution, so we don't have to do graphing. Okay, one more. Let's take a look at number 6. Again, no variable is by itself. This time I have 2 variables that have a 1 in front of them. The y has a 1 in front of it, and the x has a 1 in front of it, except for the x has a negative symbol. So I'm going to say, let's go ahead and let's isolate this. It'll be one less step. So let's move that x over. And it looks something like this. We're going to plug that in, and we're going to have a new equation. Distribute. Combine like terms. You will notice the x's cancel. You will also notice that you have a false statement, and you should remember that if you've got a false statement, there is no solution. Meaning, if you were to graph this, they would never cross. Meaning, if they're never going to cross, they're going to be parallel. You also should remember, if these things are parallel, they will have the same slope. Okay, so that is day 2 on substitution. Your homework that goes with this is going to be make sure you show all your work. and have a good day.